Okay, let's move on to chapter 4. We're going to be talking about congruent polygons, and specifically this chapter, we're going to be talking about triangles, congruent triangles. First thing is, what does congruent mean? Congruent basically is the geometric term for equal. Like, we'll just leave it at that. It's the geometric term for equal. Like equal lengths, equal measurements. So we say if we take a ruler and measure two segments and they're both like 7 centimeters, we say the lengths are both 7 and we say the segments are congruent. Congruent polygons. So what does it mean? What does it mean when two polygons are congruent? What is that? So we say that two segments are congruent. Can we say that two triangles are congruent? Can we say two quadrilaterals are congruent? That's what we're moving toward, the relationship. We've defined what triangles are. We'll quickly, isosceles, right, square, rhombus, right? We'll define that, but we want to know about the relationships between the two objects. So congruent polygons have congruent corresponding parts. Congruent polygons have congruent corresponding parts. And the idea is, well, we saw that word corresponding when we did the parallel lines, and we drew the two parallel lines, and we said this region up here corresponds to this region down here. And we asked ourselves, 1 corresponds to 5, but is it congruent? 2 corresponds to 6, but is it congruent? So that's what we want to do with these polygons now. So the first thing you're going to do is, when presented with 2 polygons, is first match them up. So my example I give is like I hold my hands up. So I don't put I don't match my hand here and say, oh, this finger is bigger than this finger. First I match it up, and then I put it together. And then once I've matched it properly, then I compare the corresponding, my fingers. So first, match the figures. First, match up the figures. And second, compare all the corresponding parts. Sorry, guys. Corresponding parts. Okay. So let's say that, first example, I'm going to put up a trapezoid. And I'm going to put up a triangle. Here's figure 1. Sorry, I didn't tell you what they were. So here's 2 figures. And let's call this figure A, B, C, D. And this figure over here is E, F, G. And the question is, are these 2 figures congruent? Are these polygons congruent? Remember the symbol for congruent? That's a question mark. And the answer is no. Why not? Maybe this is 3, and this is 3, and this is 3, and this is 3. Maybe this is 5, and this is 5, and that's 7. So, well, they match up, right? No. No. One's a no. Like A, B, C, D is a quadrilateral, and E, F, G is a triangle. So, no, they're totally not going to be congruent. They're not even the same thing. Okay, let's move on. Oh, you know what? Can I put the shape down here? You know what? I'm going to do that so I can save space. Okay, let's take a look at the next. How about we'll take A, B, C, D again, right? So here's A, B, C, D. Use a ruler. So here's A, BCD, and here is another figure. And here's EFGH. And let's see if these are right angles. Right? And so by inspection, are these congruent? And you would say, so the question is, are these congruent? Are these congruent? How are you doing for time? I think I have you in like 10 minutes. Oh, we're good, we're good. And you would say, what would you say? You say, no, why not? You'd say, well, although they're both quadrilaterals, although they are both quadrilaterals, what do you know? What else? But the corresponding angles are not congruent, right? What's not congruent? Well, A is congruent to E, okay. D is congruent to H, right? But just based on our picture, we can see that D is not congruent to F. And C is not congruent to G. And yes, I told you, yes, we don't know what the measurements are, but we can see where the idea here is. Next, so now I'll give you two polygons that are congruent. And let's take our ABCD. So let's see, we have So here are two So here's A, B, C, D, and here's E, F, G, H. Now I'm showing you that this is congruent. Now this is congruent, blah blah, and I'm saying that A. Let's see. What am I saying is congruent? I'm saying that AB is congruent to EF. I'm saying that CD is congruent to GH. BC, and then I'm saying 1, 2, 3, 4, 1, 2, 3, 4, and I'm telling you that this is 100. Now, are these congruent? And you would say, yeah, Mr. Rather, they're congruent because if I match everything up, they're all congruent. So once again, and so you would say, yes, Mr. Rather, I match them up, they're both trapezoids, we'll learn about that, and all the corresponding sides match up, and all the corresponding angles are congruent. I know the base angles are both 90 degrees, I know that B is congruent to F, and therefore what's left over is congruent. We will learn that a triangle has 180 degrees, a quadrilateral has 360 degrees, and some of it interior angles, and they keep going up by 180s. We'll prove that. So you say, yes, they're congruent. So yes, these quadrilaterals are congruent. Okay, well, how do we write that statement down? Because we want to know how to write the statement. So the idea is when you write the congruency statement, the congruency statement will show us all the different angles and sides that are congruent. The congruency statement the congruent shows all the corresponding angles and segments. So I can't just write what I cannot do. What I won't do is I will not say that A, B, C, D is congruent to H, G, F, E. I will not do this. Once again, because this isn't showing, although these are congruent, this statement does not show the proper matches. So what I'm going to do is make sure everything matches up. So I'm going to say, but I'm going to say A, B, C, D is congruent to E, F, G, H. And this congruency statement, with or without a picture, tells us exactly what matches up with what. The congruency statement tells you that angle A is congruent to angle E, angle B is congruent to angle F, angle C is congruent to angle G, and angle D is congruent to angle H. The congruency statement also shows me that AB is congruent to EF in a way that fits AB, EF, in a way that this didn't exactly, it wasn't right. AB is not, once again, we kind of know this. We know what the person was trying to say, but it's not the best way. No, you do not want to say it. This is better. AB is congruent to EF. BC corresponds to and is congruent to FG. CD corresponds to GH and is congruent, right? I mean, look at that, right? CD and GH not only match up, but they're congruent. That's the idea. And then the last thing, what do we have? AD, and EH. AD is congruent to EH. Now, obviously, we're mathematicians, we're going to do it faster way. So in the next couple of classes, when I ask you to determine if two triangles are congruent, we're going to come up with a faster way. I'm obviously not. Today, you have to show me that all 6 sides and angles of the triangle are congruent. Tomorrow, we're going to come up with something a little faster. But we're only on the first day. So, once again, if you're told, notes, this, once again, we've been doing proofs, and it's always like, what's in the if statement? What are you telling me is true? If I tell you that 2 things are congruent, all the corresponding parts are congruent. If you are told that 2 polygons are congruent, then all the corresponding parts are congruent. Then all the corresponding parts are congruent. Once again, you're just looking for someone to say, oh, this is true. You just grab that and use it. Oh, those 2 triangles are congruent? Okay, that means those sides are congruent. Oh, you're telling me the 2 triangles are congruent? Oh, that means those angles are congruent. Like, you use it for what you need. And so, okay, question. So here's 2 triangles. You're going to see this a lot. This is a thing. They like this. The bow tie. They love the bow tie. It's a thing. Sorry. Let me make it a little better. And once again, it's not the best picture. You're told that you're given this diagram. A, B, C, D, and E. And you are told that angle A is congruent to angle E. You're told that angle B is congruent to angle D. You're told that AB is congruent to DE. You're told that BC is 4, CD is 4, AC is 6, and CE is 6. My question to you is, are these triangles congruent? And you say, okay, well, I need to match up all the sides and the angles. And you're like, okay, well, I know that AB, segment AB is congruent to segment DE. I know that BC is congruent to CD. I know that AC is congruent to CE. I know that angle A is congruent to angle E. And I know that angle D is congruent to angle B. I only have 5. Is this a problem? How do I get the 6? Any suggestions? Anyone? I guess these triangles aren't congruent. I wasn't told. Oh, wait, what? You're saying that angle 1 is congruent to angle 2? Why? Oh, they're vertical angles. Nice. Can you see that? Vertical angles? Yes, vertical angles. Therefore, we've proven all the corresponding sides and angles are congruent. Therefore what? Triangle ABC is congruent to triangle, ABC is congruent to what? EDC. Can you see that? Can you see that? Yeah. Remember, A corresponds to E, B, D, C, and C. And AB, ED, BC, CD, perfect. We just proved something. What did we just prove? What did we just prove? What did we just prove? Theorem. If two angles of one triangle are congruent to two angles of another triangle, then what? Then the third angles are congruent, right? And we can quickly do this. I think we've done this before. I mean, we technically have, because if you consider two angles supplement together, if we know that A plus B plus C equals 180, and we know that D plus E plus F equals 180, that's given. Angles of a triangle equal 180 degrees. What else? What's given? What's in the hypothesis? What's in the hypothesis? Well, you say, okay, well, Mr. Adler's saying that A is congruent to D. What else was in the hypothesis? That B was congruent to E. That's given. So what can we say? Well, we can say that A plus B plus C equals D plus E plus F, substitution. Substitution, I can also do, this is D, right? And this is E. That's also substitution, right? And then the last thing is that C is congruent to F. Subtraction. Subtraction, postulate of equality. So, we just proved if you have two angles congruent to two angles of another triangle, the third angles are congruent. Doesn't necessarily mean they're congruent. Sorry, Siri. Let's move on. Number 5. The last problem. Last problem and then we're done. Last problem and we're done. Try this one. So here's another diagram that they like. Here's a line, and there's two triangles that come off of it. Let's see. And this is L, N, M, O, and we're given statement, reason. We're given that LM is congruent to LO. We're given that MN is congruent to ON. We're given that angle M is congruent to angle O, and we're told that angle 1 is congruent to angle 2. Angle 1 is congruent to angle, I can't see my screen. And we're asked to prove that triangle LMN is congruent to triangle LON. How do we prove those two triangles congruent? Well, I have to go find all 6 corresponding sides and angles. So I have the LM, 1. I have my MN, 2. I have my angle M, and I didn't tell you what 1 and 2 was. That is these angles right here. MLN is angle 1, and OLN is angle 2, but I'm just too lazy to write them out, so I use numbers very neatly so everyone can clearly see what I'm doing. The problem is I only have 4. I need the other 2. Well, we just, any suggestions, take a side. Okay, well, you know what? I'm going to stick some numbers in here. This is 3, and this is 4. Can I prove that angle 3 is congruent to angle 4? Yeah, we just proved it over there. If 2 angles of a triangle are congruent to 2 angles of another, then the third angles are congruent. We just proved that. We're done. I only have 5 now. Okay, so we know that angle 1 is congruent to angle 2, and maybe you want some colored pens. That's totally fine. 1, 2, 3. 1, 2, 3. I have the last side. Where's my last side? Oh, well, it looks like that's, well, what side's missing? Oh, it's LN. Well, they're both LN. So is LN congruent to LN? Is that true? Yeah. Why? Reflexive. Now, can we make our conclusion statement? Yes. Why? Triangle LMN is congruent to triangle LON because all corresponding sides and angles are congruent. Done. QED. We're finished. We just proved that those 2 triangles are congruent. Homework on Google Classroom. Sorry this was so long.